We talked yesterday about how in our new unit with exponents that we're going to be adding and subtracting. So yesterday we were multiplying powers with like bases. Now today we're going to see something different. Whenever we see a fraction bar, we want to think of the fraction bar as dividing. Okay, so that's one thing we want to make sure we can get. The fraction bar equals division. So we're now going to do a couple examples. I just want you to follow along. So I've got 2 to the fourth divided by 2 squared. That's going to end me up with 2 squared. Okay, we're going to try some more. C to the fourth over C to the third. That's going to get you C to the 1 power. Then I've got x to the eighth over x to the sixth. That's going to get me x squared. Now here, if I've got multiplication before division, okay, I want to do the multiplication first, but I'm going to do this part twice is what I want to do. So I'm going to copy this. It looks kind of gross, but that's okay. All right. The first time I'm going to do it, I'm going to combine the top. So when I combine the top, I get x to the fourth and x squared. That gets me x to the sixth over x to the fourth. Okay. Then I would go x to the sixth divided by x to the fourth, and that gets me x squared. So the other way I can do it is if I recognize that I was dividing x to the fourth and x to the fourth, it looks to be the same thing. When you divide the same thing by the same exact thing, those just cancel out and give you 1, and then I would see that would leave me with just x squared. So if I knew that property, the division property of being able to cancel out things, that you divide the same exact thing, they equal 1, I could just get to that. All right, now here's one with some different letters and numbers. So I've got a to the third over a squared. Since those are the only like powers in the division part, I'm going to divide them right now. So a to the third and a squared. That's going to be just a to the first power up on top. Then, since these are next to each other, that means multiplication. So I'm going to multiply b squared times b to the seventh. Well, when I multiply powers with like bases, I add. So I got a to the first, b to the ninth power. Now you should be thinking in your head, hey, what is this that we're doing? What is the rule? What do you think the rule is? Well, here's your rule. The rule is when you divide powers with like bases, you subtract the exponents. Go ahead and write that down in your box. But we also have some conditional things that we need to make sure we know. Like you want, ooh, not in all caps, you want to simplify multiplication before you start with division. So anytime there's division or there's multiplication first, like if we go back and do number, or this one right here, if we look at this one, see how there was multiplication first? X to the fourth times x to the sixth up top. We want to do that first before we eventually divide. Okay? If you think PEMDAS, okay, if you think PEMDAS, what comes first? Multiply, then divide. So whenever we do this, we want to multiply, then divide. Okay, go ahead and hit pause on the recording and start to work on this practice part. All right, you should have gone and tried to do most of these. I'm going to skip down and do number 9 for those of you guys that are just hanging out waiting. Here's number 9. I want to make sure I make this b to the first. And I've chose this one because it has multiplication on the top before division. So it has multiplication between the b's, b to the first, c to the 12th, b to the 8th. Well, the like powers, powers with like bases is b to the first and b to the 8th. Well, those will combine to get me b to the ninth power. Then I have c to the 12th over c to the 8th. Those are going to subtract since their powers like bases. And that gets me c to the fourth power. So I get b to the ninth, c to the fourth. should have gone through. Go ahead, if you did not do the rest of them, go ahead and try to do the rest of them based on that. Okay, here's the rest of your answers here. This one subtracts. This is going to be 2 squared. 5 minus 3. This one is going to be 3 squared. So here I want to multiply them together. I want to get this to be c to the 13 first over c to the 8th. That's going to simplify to be c to the 5th. This one over here, the only like bases are x to the 13th and x to the 5th. So when I subtract those, that simplifies to be x to the 8th. And then my y to the 6th stays the same. And my z to the 4th stays the same. Over here, 2 over 3 stays there. So I leave that 2 over 3 since they do not have a like base. C to the 12th and C to the 3rd, that subtracts to be C to the 9th. And then I get my D left right there. For 6, I would subtract these. This is going to be x to the 5th power. 7 is going to be y to the 5th power. I've got my A's and B's I need to get done. So my A's, if I subtract, I need to do multiplication first. Sorry, people. My B. Let's see, b to the 3rd times b to the 7th, that gets me b to the 10th. And then a to the 8th minus a to the 4th, that gets me a to the 4th. Now I'm just going to write my a's before my b's because I learned my alphabet that way. All right, 10. I've got to put my ninja 1 there and combine them, so that gets me a to the 13th over a to the 9th. Subtract those. That turns out to be a to the 4th power. Number 11, I'm going to combine my top to be x to the 6th over x to the 4th. Subtract those, that gets me x squared. That's also the one where, since they are the same exact powers and same exponents, or bases and exponent, base and exponent, you can just cancel those and get your x squared. Okay, I'm going to combine my a's on the top. That gets me a to the 10th b squared over a squared. Subtract my like bases. That gives me a to the 8th power b squared. Alrighty, there you have it. There is your practice. Here is a little thing to see if you are having trouble with this. Let's say if I was doing number 2. 3 to the 3rd can also be written as that, and 3 to the 1st can also be written as this. So we divide. We're talking about this property where you can cancel them out. So I can cancel out these 3's because they're dividing. They just equal